Starting recording again, and welcome back, everyone. We are on our second session of Introduction to R, the beginning of you falling in love with R. And I believe that today, at the end of the lecture today, you will definitely start seeing the amazing things R can do, because I plan to, let's see how it goes, but I plan to reach the ggplot, the grammar of graphics, at the end of the lecture. The grammar of graphics, I will tell you a little bit more about this at the end of the lecture, but just for now, to keep your interest up, then it is one of the killer apps for R. It is the reason why people use R. It is the most, if you are doing these publication-ready visualizations, then this is the way to go. These visualizations are, there are two things why you would use the visualizations. One is to understand your data yourself, and the other one is to show your results to others. So first, I am going to share my screen again, and what I want you to do is open the RStudio. Open the RStudio, and it should. Is everything okay now?
Yeah, it's visible. Yeah.
You see it well. It is not too small. It is not too big.
No, it's fine. It's absolutely fine.
No. And what I'm going to do, I'm going to create for today's session, I'm going to create a new R script. So first of all, if you start RStudio, then it usually starts with the same project you had at the beginning, you know, that you had opened last time. But for some reason, RStudio has had a bug, and maybe it doesn't have this bug anymore, that sometimes it kind of shows that you have opened the project, but you have not actually opened, it has not actually opened the project. So what I recommend and what I do usually myself is that I do this file, recent projects, and open the project explicitly again. I open the project again, what I want to use. So you usually when you have different things to do in R, you have different projects going on. And open the relevant project, and I'm going to create a new R script for today's session. File, new file, R script. And save it as second seminar. .r. Now first let's quickly look at the homework, and I'm going to do this homework myself. I'm going to do it myself. So we had this GDP dataset read in. If you do not have this read in, then I'm going to copy and paste it into the chat, the code. I have no idea how can I find the chat. Oh, okay, now you see I have, here it is. I'm going to copy paste the code here. So read in the GDP, Control Enter, and you have the GDP dataset read in. Now in the homework, I wanted you to, well, let me tell you a quick story about this GDP dataset, still, that you understand what's going on. It's not so important. It is a little bit Estonian centric, and I'm sorry, my data is a little bit Estonian centric, because I have usually taught it in Estonia. I have taught internationally as well once. I have taught in, can you imagine where? I have taught in Saudi Arabia, in Riyadh. I have had my R course. So it shows year, quarter, and then GDP estimate. GDP is gross domestic product. It shows the economic growth. It shows the first estimate is something that the statistical offices are giving out at first. They are giving out this first estimate very quickly after quarter ends, and then they are going to reevaluate this. As the more data comes in, they are going to give their new estimates that, hey, not during this quarter, the economic growth was not this, but it was actually bigger or smaller. So there is first estimate and then latest estimate, and then there is a date variable. So it shows how much where was the statistical office wrong with the first estimate. Now, what I asked you to do first is I asked you to create a new variable difference into data frame GDP so that it would contain the difference between first estimate and latest estimate. For this, you would create GDP. Actually, you know what? I'm going to reverse course. I'm going to do this in a second, but first let's go through what we learned last time. Let's go very quickly. I'm going to go through what we learned last time. So we learned the basics of RStudio and how to use RStudio. And it is that you create a script file, you write something into the script file, and then you Control-Enter on this line. Anywhere in this line, you click Control-Enter, and it shows you the answer in the console. It sends this script, this command to the console, and it executes the command in the console. R actually lives in this console. The rest is user interface. We learned how to create data objects. For example, A is 15, Control-Enter. And we learned that this is the assignment operator is this kind of arrow, which is a smaller than and then minus. There's a funny story about this assignment operator. So in most of the modern programming languages, assignment is something that you do a lot. So it is a one character operator. But in R, it is 2 characters. It's smaller than and minus. And some programmers go crazy. Oh, why is it 2 characters? But this has historical roots and reasons. The case is that when in 1968 or whenever the S language, the predecessor of R, was created, then there was this kind of key on the keyboard that created this arrow. And the key has long gone from the keyboards, but the arrow has stayed. So you learned how to create data objects, how to assign values to them. And then we looked at how to remove these data objects. And this was done with RM or remove A. And now the A is gone. We don't have A anymore. If I call out A, it says error object A not found. Then we looked at that many things in R, that R is a vector-based language and everything in R is a vector. To create a vector, you would do it like this. My vector is assigning values to my vector, and now it is a small c, and then the parentheses start, and for example, 3, 4, 5.6, and 7. And now I have my vector created, which has 3, 4, 5.6, and 7 inside it. So the separator is always the comma, and dot is the decimal point. In some languages, the decimal point is comma. In R, it's always a dot, like in English language. So we looked at that. We looked at that actually the main data structure that we use in R. It is a data frame, and we have this data frame GDP here. It has a number of vectors inside: year, quarter, first estimate, latest estimate, date. To access these vectors, you would use dollars. GDP dollar year will give you all the years, this vector of years, or this column of year or variable year. It shows you all these variables. We learned that to create a new variable in a data frame, then you would say, and this is the first thing we needed to do in the homework, is that GDP dollar difference. I'm creating this new variable difference into the data set GDP, and now I'm assigning something to it. And I'm saying that this should be the difference between first estimate and latest estimate. So how to access first estimate? It is GDP dollar first estimate minus GDP dollar latest estimate. Control-Enter. And now if you look at the GDP again, then it has a new variable. It has this latest estimate. It has this difference variable inside it, which is the difference between first estimate and latest estimate. Now, if we learned that in R there are functions in R, functions or commands, and function is always like this: that function name, and then parentheses. And inside these parentheses, you will put inputs to these functions. You will put what is called arguments. What kind of argument a function can take, what kind of argument you will never learn these by heart, but you can find them out by pressing question mark and function name. So for example, question mark and mean gives you that mean has arguments x, trim, not available, remove. If these arguments in this help file have already a set value, for example, trim is equal to 0, then you do not have to change it, but you can change it if you want. If it does not have this set value, then this is something that the function needs to go on. It absolutely requires this, that you have this, this argument x. For example, mean x is different, is GDP dollar difference, gives you the average of difference. Now, there is one thing that I did not tell you in our about these functions yesterday. It is that you don't actually need to write this x. You can write it like this, because when it sees that there is an input coming in, it automatically puts it into the first position of the function. So the first position is x, it requires x. I don't have to write x is this, because it already knows that this has to be x, because it is the first input of the function. So this is how we found the average difference. This average of this difference variable in GDP dataset. It is minus 0.00. So on average, the first estimate is, it doesn't have a big bias. That first estimate is always bigger than the latest estimate, or first estimate is always smaller than the latest estimate. On average, it doesn't have a bias. Then I wanted you to create a variable absolute difference into the data frame containing the absolute difference between the two variables. And I told you that absolute can be found with this function, abs function. So I'm going to create into GDP a new variable abs difference. And I'm saying that this is absolute of GDP dollar difference. Now it created a new variable abs difference into the dataset GDP. It is absolute error, how much we were wrong, either to minus or either to plus. So if we look the mean of this GDP abs difference, then we see that it is 0.014. So on average, the error was 1.4% in economic growth. On average, the first estimate was wrong by 1.4%.
Sorry, just a quick one. This GDP absolute difference equal to absolute bracket GDP. I mean, what's the difference between the both arguments? Are they same, or just a difference in title? I mean, on command 21.
So I created a new variable which I named abs difference. I used function called abs, which find absolute value. Absolute value is absolute value of minus 1 is 1. Absolute value of 2 is 2. So it turns all the values to be positive. So this abs function, what it needs, if you want to see what it needs x. It needs a variable to find the absolute of. I'm not certain that I'm answering your question right now very well, but what was
I understand. I think I understand you better now. But what I want to the one last question: do we have to call the absolute function before using it on our arguments? Like what I noticed, you call the absolute on line 20.
No, I didn't call. No, you don't know. You don't. I just saw. I just wrote it. I didn't call it. I just wrote it. I commented it out now. No, you don't need to call it. I just wrote it that this is a function. Let me. The function to use is abs. So now I commented it out, that this is also something that we learned last time, that this hashtag is the way to comment comment something out. Now, Chering, you asked that to create a variable difference, do I need to input GDP dollar? Yes, you need to take the absolute difference from some variable. So we are taking it from variable difference in the dataset GDP. So absolute of this variable is a new variable abs difference inside the same dataset. So if you look at the dataset now, view GDP, then you see there is now, apart from this year, quarter, first estimate, latest estimate date, there are the two new variables that we created, difference and abs difference. Or you said you have an error message. What kind of error message do you have? The key is to always it will work in this way, actually, but you are creating a difference data object in R. It will not go into the GDP dataset. Usually you want to get it to the same dataset. So Ovi, you do not have GDP loaded in. So what you need to do is, if you go up a little bit, there is this, I'm going to copy and paste it again. You have to run this code, Ovi, and Control Enter, copy paste it and Control Enter, and then you will have the GDP data set. Giving you a bit time to run it, but okay. So now the average error during that period, we found it, this GDP, this mean of GDP abs difference, we found what is average error on this data set. Then there was this find the correlation between first estimate and latest estimate. You should use a function cor, which takes two parameters, the variables for which the correlation is to be found. So this would be correlation, and now it needs two parameters. I find the correlation between the first estimate, comma GDP latest estimate. And it is 0.96. The correlation is high. Doesn't make any sense anyway to find this correlation, but to let it be. Now, the next thing I asked you to load in is load in the PIAC dataset. And this is, you use the read.csv function. So it will be like this. PIAC, you are writing this into a data object, the output of the function, read.csv, and now the address http www.ut.e /e-seppo PIAC eng.csv Control Enter, and it loads it in. I'm going to copy it. We are going to use this PIAC dataset a lot. I'm going to copy the code into here as well. So into the chat. So what this PIAC dataset is actually, let me talk to you a little bit about PIAC. Now, I don't know if you know PISA tests. PISA tests are something that are performed globally. They are trying to evaluate the mathematical and literacy skills of students of, I think, 14, 15 years of old. It is mainly done in OECD countries. I don't know if your country is part of this PISA tests or not, but this is how many countries evaluate the effectiveness of their education system. Now, PIAC is something similar, but it tries to evaluate the mathematical skills and literacy skills of adults. And this is also done in many countries. And what I love about this PIAC is that the data is publicly available. So it is amazing source. When I teach, I usually use this PIAC data because it's publicly available. It's a very rich data set. It has a lot of things. It has people's wages. It has their age. It has a lot of things. And then the evaluation of how good they are in mathematics, how good they are in functional literacy, how well do they understand some texts, and so on. So you can see how much, for example, if somebody is good in mathematics, how much does someone earn? If somebody is bad in mathematics, how much less does she or he earn, and so on. I have only taken a subset of this PIAC data set, and I'm using Estonian data here. And this is some 15 years old data, but right now in Estonia, the new round of PIAC is running. I don't have the data yet. So it's a bit outdated data, but it doesn't really matter. What matters is that it has all kind of different numbers inside it, different variables inside it. And right now, I have selected only some variables. Sequence ID, this is ID of a person, age, gender, employment status, living with spouse, yes or no. Does the person have children? What kind of education does the person have? Education in secondary, higher, lower, or educate six categories of education. Then there is earn hourly. How many euros does the person earn hourly? Then there is literacy and numeracy. These are the results of the tests. Problem solving skills, another test. Study area. What did the person study when she or he was still studying? What is the health? How he or she evaluates health? What is the monthly income? And then a weight. So everybody has a different weight here. This is a weighted data set. Not weight as in how many kilograms do you weigh, but statistical weight. Adebayo, so it is not saved to your computer yet. It is read from the internet. The question was that what is the CSV file on the PC? How is it read? If you want to read something from the PC, then let me save this PIAC. To write the CSV file, you would say write CSV PIAC, and now file is, what file do you want to write it? Let's say piac.csv. And now if you look at your files, then it shows that inside this project directory, it wrote piac.csv. It wrote it into your computer. To read it in, Arinjoy, you asked that when I'm viewing that I am reading the questions, because I noticed that in the YouTube, when you watch it, then you cannot see the chat. So I'm reading the questions out, so that when you are viewing the data, so the question is that, okay, first I'm going to show that if I want to load this data now from the project directory, then I would do piac is, or piac2, let's say, is read.csv, piac.csv, and now it reads it from my computer. Now the other question was that if you look at this piac, then it shows that reach max omitted 6,142 rows. It does not show you the whole data set in the console. It shows you only the beginning of the data set. If you want to view the whole data set, you would do view piac, and now it as well, and now you can see the whole data set. You can browse it through. There are 6,204 observations of 16 variables. So there are 6,000 observations. 6,200 people have been measured. So the question was, how big is the data set? How many rows? How many columns? There are two ways to see it. One is to look at this environment, and it shows 6,204 observations. So this is the number of rows and 16 variables. The other would be to use a function called dim, dimensions, dim piac, and this will also tell you the first number is how many rows does the data set have, and the second answer is how many columns does the data set have, or how many variables. Ovi raised the hand, but Ricardo, you said that object piac not found. It should work. If you can't, Ricardo, you could not read in the data set, so it was like this. What you are missing the last this parenthesis, Ricardo. Now if you do Ctrl Enter, then it reads it, and you have the piac data. Ricardo, did it go well now? Were you able to? I don't want to lose anyone. I don't want to. Ovi, so 26. Okay, sorry, I'm moving fast. Yes, I have this problem that I might be moving a little bit fast. So 26 shows the correlation between GDP, first estimate in GDP, and second estimate of GDP. What is the difference between PIAAC2 and PIAAC1? PIAAC2 I read in from my computer. I first wrote it to my computer. I wrote dataset PIAAC into the file piaac.csv, and then I read it in. Now, why does PIAAC2 have one more variable? It is because this write CSV, it is a little bit stupid. It writes to every line, it writes the first is the line number, what it writes into the file. So when you read it in again, then it has these line numbers as the first variable. So I was a little bit too fast. I will take a little bit down my tempo.
No, sir, it's not too much fast, but you're taking a lot of questions. So this is opportunity for those who are not in the same. Whenever someone copy the code from the chat, it should be very think, is there any comma, something is missing or not? Because this is very important. If you miss a single dot, there will be an error.
Okay, Kasper says that I copied the wrong link to the chat. Maybe I did. Now there is a better link there, I think. It should work. So I don't want to go on up until everybody has this PIAAC read in. Yes, if there is some percent 22 in, then it's a problem. It has to be exactly like this. You have to find this tilde from your computer, and we are going to use this tilde much more. So, who had O'Canary? Were you able to please confirm that you were able to read this data set? Okay, I will view Ovi, the view which is big V, is big V, which the first V is big. So it has to be, you see, this first V in view is big V. Capital V, yes. I know there will be always, okay, good. There will always be technical problems, so I don't want to leave anyone behind. Now there was a bonus exercise for the quickest. It was about using the function quantile. And what quantile gives you, it gives you, well, quantiles. Let me the 10th, 15th, and 19th percentage of income in the PIAAC dataset. So quantile, from which dataset are we finding, from which variable are we finding quantiles? We are finding it from PIAAC dollar income. And I think in the text I use income with small e, but it's actually with big E. And then quantile wants the quantiles, which percentiles do we want? So 0.1, 0.5, 0.9. And also it wants this NRM is true, because it cannot find quantiles from if the data has not availables inside. So what did I do now? What did I find? This means that 10% of people earned less than 322 euros a month. 10% of people earned more than 1,670 euros a month. And the median was 725, so half of people earned less, half of people earned more. Now, just as a side comment, this was, as I said, 15 years ago. So by now this 1,600 is around average wage of Estonia. Not that you care about the wages in Estonia too much, but this has changed a little bit during the last 10-15 years. So let's look at the quantile help. What it says that it wants to have X, so it wants to have variable from which to find quantiles. And then it wants to have this probes vector. So which quantiles to find? I am going to explicitly write it here. And then it has this NRM argument. So these arguments it wants to have. And I'm saying that find quantiles from income variable from PIAAC, the 10th percentile, 15th percentile, and 19th percentiles. This is the probabilities of probes vector, and NRM is true. I'll enjoy. But this is not so important actually right now. This was a bonus exercise. We will get to this later. I saw that two people, it showed me somewhere that two people raised hands. Do you want to say something? Do you want to write something?
Yes, sir. Just a short question. In line 44 earlier, what's the difference between putting C, then open and close parentheses with 0.0, 0.1, 0.7, 0.9?
You mean this sequence, or what is the difference between putting
C and yeah, because I ran the code without C, then I only got 10%. Then when I add C, it shows the 10%, 50%, and the 90%.
Well, this is the case of ours, that everything it needs a vector. If you put in 0.1, 0.5, for example, then
yes,
see it thinks that this 0.5 is some kind of other argument. You want to say that probes is 0.1 and 0.5. Otherwise, it thinks that this is some kind of other argument and it cannot interpret it, and it just ignores it. But if you put the C around it, then you explicitly tell it that this is
included. Okay.
Yes, that this is a probes argument. So we need a lot of vectors in R, and this is when you want to give many arguments to one, many inputs to one argument, then it's gonna be a vector.
Thank you.
But actually, when what we did right now, it shows that by now you can already do quite a lot of things in R. So we read in data, we found something, we created new variables in the data, we found the average error, on average how much we are wrong in GDP estimates and stuff like this. So when you want to communicate it back, or when you want to send this information back to somebody, then you usually, what I already showed you, you want to save this file with your new variables. You want to save it, for example, as CSV file, comma separated values file. To do it, as I showed you, there is the write.csv command. Write.csv, if you look at the help file, then it shows that it wants X, it wants file argument, and then there are a lot of other arguments that you can give, but all of them have some default values. So write.csv wants to first know what are we writing out, for example, this GDP data. Then file is, what file is it going to write it out? Let's say gdp.new.csv. And then some other arguments. For example, there is row names is false consonantal, then it doesn't write down the row names. It is a stupid thing that by default it writes down the row names. But this every time you save a CSV, it writes again the new row names 1, 2, 3, 4, 5, 6, 7. You don't really need this. So this is how to write files in R into your, and when you look at your files pane now,
Sorry, just a quick one. I wrote the 48, and on the console, it just gave me exactly the same thing I wrote just above. So I was hoping that I would see the counter appear just the way it appeared like yours. So what could I have done differently that it didn't appear like yours?
what didn't you wrote this and you clicked console enter? Yes.
Yes, it just appeared like yours, quantile, like exactly the same thing I wrote. The same thing you wrote in 44 appeared on the console without giving me the output. Like yours is showing quantile and the percentage just below.
I do not understand, sorry.
Okay, let me share what I have on the, maybe to.
I don't know if it's possible to post a screenshot in the but write the copy and paste the write CSV command.
Sorry, just to jump in, maybe you should just help us explain from 43, because I'm still having the same error. I think similar to his, where I just wrote mine just like yours of 44. So I had exactly what you wrote on 44, but I'm still having error. So I'm thinking if you could kindly help us with just explaining from 43, and then we could maybe that could
44
help.
you have an error.
Yes, error is unexpected symbol in quantile pag info. So unexpected symbol anyway. That was the error message I got.
Unexpected
symbol. Or I could share it. I could share my error too.
Yes, please share your error.
Okay, thank you.
Kasper, I'm answering you at the same time. So if you look at this question mark and write CSV, then you see X does not have any default value. X is just here. The others, for example, append has default value false, quote has default value true. You can see it from here, which are the default values. NRM by default is always false. For example, if you look at here, then okay, this right table doesn't have NRM. Okay, Ovi, your problem is that income has to be with big I, not small I. The last line you wrote, this will work. Canary, you don't have last. You are missing last parenthesis after the quantile. So let me show you one trick or one problem what you could have. So let me forget. Oh, sorry. Okay, Neri, you have another problem. You're not only last parenthesis, but you are listening. You are missing this parenthesis here. Can you see? Okay, Neri, this?
Yes, I can now.
Yes. So. But let me miss, for example, this parenthesis here by mistake. Then it's going to show you. You see this plus here, and whatever you do, it is still the plus is here because it is expecting this last parenthesis. What to do in this kind of situation? You go with your mouse. You go to the console. You activate the console, and you press escape, and then you are back to the command line. And now you put the parentheses back and you run it again, and it shows. As I told you, the main problem what you are going to face is you are missing commas, you are missing the parentheses, you don't close something, you open something, but you do not close something. And this is absolutely expected. I don't know anything about antivirus and RStudio because I use Linux and I don't. It might be that some antivirus software might just let you write something. Kasper, did you get your answer? Okay, should I continue? Okay.
Yes, you can.
Yes,
Thank you.
Please, one last one. What is na.rm? What does it mean? Na.rm. I know
Since-
RM is remove. What is NA? Yeah.
It doesn't, what it does is that it doesn't take into account the not available, so missing values. So if there are
Okay.
missing values, then are.
Thank you.
Now we are going to look how to save files in Excel and everything else as well later on. But for now, I'm showing you a little bit more about saving data. So R also has a native data format, and this is if you want to save it, this is important when you do some analysis, a long analysis, it runs a couple of hours, and now you want to save your results, this middle results or something. You don't want to run this analysis again next time when you run the code. So then you would use save GDP, then it wants file argument, for example, gdp.r. This saves the file in R's native format. Now there is one problem with this R's native format. The problem is that it is not portable. So in many cases, you cannot send this file to your friend and your friend cannot open it. Because it depends. Yes, Kasper, it always saves the files. If you do not give it anything else, you just say the file name, it saves it always into the directory of your project. This is why the projects are important. All the files are by default here. All the you save it in your project directory. But that was this. Now I saved this GDP data object into file gdp.r. Now, when I remove GDP, you see there is no GDP anymore. It tells me that GDP is not there anymore. And now when I do load gdp.r, it loads it again. Now I have the GDP back. So this is R's native data format that when you do something then and you want to save some results at R format, then nothing else reads it but R. So you cannot open it in Excel, you cannot open it in anything else, you can only just open it in R, but sometimes it is usable. So we will. Yes, it is possible to export results in SPSS and Excel format, but we need to learn a little bit about additional. We need to learn a little bit about libraries, and we will get to there. We'll get to there today, but right now I'm not going to show you how to save it in Excel. It is possible, but for now I'm going to go through some boring stuff yet. There is still some boring stuff we have to go get over with, and then we will be ready to do the fancy stuff. So data types. And don't worry at all if you haven't gotten everything, let's say from the session, that you do not remember everything. I am going to repeat this important stuff many times. There are a couple of things I need you. So in some cases, I'm going too quickly and you should say it to me. But in some cases, I just want you to see that it is possible and not remember it immediately, because I'm going to go over it again and again and again, the important parts. Don't worry if you do not remember everything at the first pass. I wanted you to have some knowledge about it at first, and then when we're using it again, then it will start to you will start to get it. Because learning R is like learning any other language, you know, you cannot really learn more than, I don't know, 3, 4, let's say 5, 6 new words in a couple of hours. But I'm going to show you much more new words in this couple of hours. But after some times, after some practice, after some going over it, you will finally see that this kind of stuff, it's actually easy. You will get it. It comes from you naturally already. So next topic, data types. Data types. We have used numerical and textual character type variables until now. So in most programming language, text data is called strings, string data. In R, it is called character type for some reason. If you want to create the textual, if you want to create a numerical data, then it is like we did. A is 5. A is 5. If we look at class A, it says it's numeric. If you want to save textual data, then textual data or character type data is always between the quotation marks. So for example, my pet is dog. By the way, I have seen sometimes that somebody raises hand or something like this, but for some reason I don't know the Zoom so well. I have used actually other software for this kind of teachings before. So I just that you know that I see it for momentarily, it comes to my screen that somebody raised hands and then it goes away. So I cannot see it for a long time. So feel free to comment wherever you want to say something or come into the video or say something in the middle of what I'm doing, because I really cannot see if you have raised hands. Maybe I'm doing something wrong. Maybe I should, I don't even know how should I have no idea how to see this when the hands are raised when I'm sharing my screen. Just as a comment that you are not worried about this. That I do not ignore you, but I just can't see it. Now, my pet is dog. Control-Enter class my pet shows that it is character type, text type. If I call it out, my pet, it shows that it is inside quotation marks, it is text type. There are some other types in R, for example, logical type. So B is true. Now, notice that true is big letters. True. This, when I now look at class B, it shows that it is logical. It can be false or true or not available. There is also, for example, when you look at class GDP $year, then it shows that it's integer. It is only full numbers, you know, integer numbers. So there is integer data type as well in R. I wouldn't worry about this much unless you have very big data, then you want to be certain that it is integer and not integer. Otherwise, it's numerical. It is enough. Numerical can also have this commas, decimal points. Now, I told you that vector can only contain one type of data. R is something that is called weakly typed language. Yes, floats should be under numerical data types. So R is something that is called weakly typed language, and this means that R will change the type of variable itself. It is very useful when you do this quick interactive work, but sometimes you can make errors because of this. So many other languages, when you define a variable and you say that this can only contain strings, and you try to put something else into, let's say numbers, and when you try to put a string into this variable, it throws you an error. In R, it will not throw you an error. In R, it will automatically change the type of variable. Dates is a different format, and we will see dates in 30 minutes. how to create dates and how to do everything with dates. So let me show you one thing. So let me create a vector having inside 3, 4, then a cat, and then 5. And now Ctrl Enter. And you see what it does. It creates you 3, 4, cat, and 5, but it's in quotation marks. So it looked at this like it. Hey, we have a 3 here. This is a number. We have a 4 here. This is a number. We have a cat here. What kind of number is a cat? It's not a number. It's text. So it converts everything to text. Vector can only have one data type, and if it automatically converts it to the data type, that is the most that it can well, here it can convert everything to text, so it converts everything to text. To convert between data types, something you want to convert between data types, this is done as this. So let's say A is 4. Look at A, is 4, class A is numeric. Now, if I want to convert it to textual 4, that is a character type or 4, then I would do it like this. A is, I'm overwriting A as like this, as character A. And now A is still 4, but in the quotation marks, so it is a character type now. And for example, if you do A plus 5, then it says you error. How can I cannot add number 5 to character 4. If you want to convert it back to numeric, then you would do it like this. A is as numeric A. Now you can do A plus 5, and it's 9, because A is now again number 4, not representation of 4 as a string, as a character. You can try to convert word into numeric format. So for example, as numeric dog, but it then says that this is not available because it cannot convert dog into number. It thinks, what kind of number is a dog? Dog. Is it number 1? No, I don't think so. Maybe it is number 2. No. So it converts it to not available. And gives you this warning, not available is introduced by coercion. Now there is something else, but I will talk about this later. Factor variables. Factor variables are very important variables, but I will not talk about them right now. But now I am going to go. There is in the materials, there is actually something about factor variables. I will talk about them later, but I will now go to talk about additional packages. A new topic, additional packages. There is still a little bit this theoretical stuff that is a little bit dull and why, and you cannot see the actual practical importance of this, but we will soon get to some practical stuff. So, but first, additional packages. Now, base R, ggplot2, yes, is one additional package. Base R comes with a number of functions, that you can use. But actually, most of the R most of the functions are in additional packages. You need to. So the functions, the package is a collection of functions, collection of new functions that you can use. Yes, actually, there is a call for a break. Let's make a break, not 2 minutes, but 10 minutes maybe. What do you think? Or do you want 5 minutes? Beer break. I don't have beer today, unfortunately. 5 minutes works. Okay, we will start at 10 minutes. Okay, let's make it 10 minutes. Some people want 10 minutes. We will start at 10 when the clock hits 10. 10. Yes, while we are at the break, I will answer your specific questions. I will stop sharing for a moment because I will put the recording on pause for the recording. Hello again. Hello, I'm back. So, and the recording is back, and I am going to show you some tricks in R. So when I said that R is mostly about writing the code, then actually there is, yes, as somebody noticed, there is this import data set here. And the import data set is exactly this, that you can, for example, I do import data set from text base. I will later tell you what this from text reader and Excel SPSS data does. But if you click on here and then you select some CSV file, then it shows you how it would import it, and you can this is a click and point and click interface to load in the data into your R. But I would always recommend you to do it explicitly, do it like, where am I now? What did I do? To do it like this, because if your code includes this line, then you can always run this code. Control R, for example, Control R and Control Enter, it runs all the code it reads in the data set. Otherwise, you have to do these clicks yourself. You don't want to do these clicks all the time. Yes, you can import Excel files this way as well, but I'm going to show you how to do it on command line as well. You can import SPSS files, Excel files, data files, everything with this. But you need additional packages for this. And this is exactly what we are going to talk about now. Additional packages in R. Additional packages in R. So, for example, to read in Excel files, let's look at the Excel files first. Then you would need additional package called read Excel. There is a package called read Excel for reading in Excel files. To install a package, to use this package, you first have to install a package. There are two ways to install a package. One is to go, can you see this packages pane here? Packages pane. And from here, you select install. Please do it with me. Packages, install, and there is a package called read Excel. You write this read Excel here, and then you click install. Packages, install, read Excel, and install. And now it installs the package for you. For me, it's going to compile it. For you, it installs it quickly. If you're using Windows, I'm using Linux. But R also works on Mac. I don't know if some of you use Mac. So it will take a little moment. But packages are nothing else than new functions. If you install a package, then it installs it into your system. Now, to use a package, you need to read this package in. And to read the package in, what you need to do is you need to write this library and is when I'm getting to it in a moment. So library and read Excel, Control Enter. And this, now you are reading the package into your session. You have to install package once once or every time the R version goes into, you know, for 4.1 to 4.2 or something like this. So every year or so you have to install the packages. But when you have the package installed, then you need to read it in like this, library read Excel. And this you need to do every single time that you start R. If you close R and start it again, then you need to read it in again, this library. And now you can use, don't worry about warning messages with Tupano. Yes, warnings are, the funny thing about R is, so the funny thing about R is, I can tell you two things about R. First, that R was made by a real gentleman. Can you believe it that R was made by a real gentleman? I am going to prove it to you in a second. So I am going to show you my browser. And one of our, you can see my browser now, yes. One of our creators was Robert Gentleman. You see, he looks like this. So R was made by these gentlemen. And other thing I'm absolutely certain is that the creators of R are colorblind. And why I am certain of this is that if you see the warnings, they all red. If you see errors, they also red. It very much makes sense to make error to be red. But it kind of doesn't make sense that all of the messages are red. Everything is red in R. Come on, makes errors red, makes the messages, make them brown or green or yellow or something like this. No, they are all red. So, and this at first it gives you, it really creates you problems because you see that something is red. Hey, there must be a problem. No, there is no problem at all. It's just that everything is red in R. So don't worry about, if you got warnings, don't worry about them usually. Usually the warnings are bullshit. Some warnings are important as well, but this is a problem. But I will show you in time which warnings are something to note.
So is it something like we can use some packages in some versions of R, or is it like we can use all the packages in all the versions of R?
Well, usually,
like if we have a relatively latest version of R, then I'm talking about that situation.
Usually it works. Usually it works because when you read these packages in, they have gone through a quality control. And they have to be always, when new R version comes out, then they have to work. But there are some packages that are not maintained anymore. And for them, it might get hard, or you might need some different version of R or something like this, but it is very, very rare. There are a couple of well-known, of some very specific packages that require this, but it is very, very rare. Usually you do not have this problem. These packages that are on this CRUN, there's this, the packages you can install in this way, that you click on packages install, they are on CRUN. This is comprehensive R archive network. This to get your package into CRUN, this means that these packages have to follow some quality standards. Now, if you read in this library, read Excel, then it provides you a function called read Excel. Read Excel needs a file to read in. So, for example, I don't have any Excel files, but blah.excel6. And then you can specify that sheet. What sheet do you want to read? What sheet do you want to read? For example, second sheet. Then you can say that range is, for example, A1 to I don't know, say 5. You can select some specific range in the Excel file, because Excel files are usually, you know, they are created like this, that the data is actually somewhere in the middle of the sheet and so on. So this is how you read in Excel files. This doesn't work now because I don't have this blah blah XLSX right now. But there are more than 20,000 libraries for R. There are libraries for everything. For I don't know, for absolutely everything. If the R is kind of the lingua franca of statistical analysis, and if there is a statistical method, there is probably a package for R available for this. Now we are going to look at one specific. First of all, let's try to. Okay, so let's install one. Yes, it does. Ricardo, it does read the row titles too in Excel. So you can actually say it. So if you look at this, read Excel. If you look at this, help file again, then what it has this path. The path is the file name. Sheet. You can say that's a sheet. You can call it by the name of the sheet or by the position of the sheet. 1, 2, 3, 4, 5. You need to read it in sheet by sheet with Tupalna. With Tupalna, you ask that if I want to read the whole file without any range and sheets, then what will be code? You need to read every sheet separately. If you,
I want to ask, this doesn't mean the Excel sheet has to be installed in the system you're using to work, or it can be gotten from cloud soon. Like this, really Excel you're using.
you need to.
This is this Excel sheets is the criteria that it must be in the system that's where the R Studio is installed, or it can be kicked off from the cloud. I just want to confirm.
You need to install the library into your system, then you can use it. So you cannot use it, or you need to install it into your computer. And to install it into your computer, you do it. There are two ways.
My question is the Excel sheet we're importing into the R Studio, like this blah blah Excel sheets.
It can also be on the cloud. It also can read it from internet.
Okay.
I think I haven't tried recently, but how to find it into your you can download the file into your this project directory. Or you can find it from your computer like this. Read Excel, then see my folder file name like this. You can also read it in from other folders like this. If it's in different folder, but I always recommend to have everything together in the project directory, because then you can copy this project directory to wherever, or you can archive it, you can zip it, and everything is together.
Indrek, morning, afternoon. Could we, in the sheets parameter, could we insert a vector for it to read various sheets? No, it has to be separate.
It has to be one sheet at a time, because R will load it into one data frame, and it cannot be, many data frames in one data frame.
Okay, great.
Ishven, you asked how to update R to the latest version. Install again, yes, install again. But packages, if you want to update your packages, what you have installed, then you go to packages pane, and there's this update button. And every now and then I recommend you to click this update button. For example, for me, it now says that I have so many packages that needs updating. I'm not going to update it during this session, but then you just select all and install updates, and you will install the updates of all the packages that you have. Now, what I want you to do now is install tidyverse packages. So, and let's do it on the command line now. On the command line to install packages, you would use function called install packages, and then let's install packages. Let's install a package called tidyverse. And this will take some time from you now, because this actually what it does, it installs many packages. Tidyverse is a it's a package that contains other packages or shows other packages. So please do it with me. Install packages tidyverse, and then what we are going to do next, we are going then to this install packages Lubridate. We need these two packages. We are going to, for the rest of this seminars, we are going to use these packages. And I'm going to wait a bit because it will take some time. This tidyverse specifically, it's quite a big package. It has many other packages inside it, so it will take some time for you. Now I have a question for you. Have any of you had bad dates recently? Or all your dates have been amazing? No one has had bad
Could you repeat your
dates?
question?
What?
Could you repeat your question?
Have you had any bad dates recently? Of course.
Yes, I have.
I will now show you how to convert any bad date to a good one in R. You will never have to deal with bad dates again. Whatever date comes up, you can convert it to a good date in R. I'll enjoy what happened with a bad date for you had.
I got stood up. I'm very embarrassed to say it, but I got stood up. Yeah, so
actually what we have done, we have now finished the first this introduction to R week 1. It is first session. So go to this link, what was copied here. I'm going to copy it again if I find it, and download the second Intro to R 2. Can anyone find this? It will be a bad date if my wife will catch me, Charlie. Yes. Well, I'm going to show you how to convert bad dates to good dates in R in a second. But for this, you will need, where is the link?
Indrek, please, I have a quick question.
Yes.
You talked about downloading your Excel into your files into the section, into the, forgotten the name of the section anyway, the right section below, right below section, and then you have to, and then you can start working with it. So I'm wondering, how do you get it downloaded into that library? I think that was into your file section. Yes, how do you get it downloaded into the file section?
You see, here what I'm showing now, this shows the path to this directory. It is actually a folder in your computer. So if you open your Windows Commander or Windows, I don't know what it is, this Windows File Manager, then you can find this folder and you can put all the files necessary to this folder. But now let's open the second Intro to R 2. Intro to R 2, I posted this link here, Intro to R week 2. So, and you will see that it starts with repeating everything. Oh, sorry. What did I do now? So, I need a Coca-Cola. Give me a second. So, okay, I'll tell you a story in the meantime. Before we start the second week of our. It's the second day, but in my file names it is second week. I will tell you a small story. So do you know what they did with me? What they did with me? What they did with me in Center. Center is Estonian think tank where I sometimes work. And let me show you my picture there. This is it's a think tank what does applied research. Now, so there is about us, and then there are all the pictures of people. And can you imagine what kind of pictures they put out for me? I wonder why would they do something like this?
We don't see your picture, Mr. Sipo.
You don't see a picture?
No, we see actually. So I think it's your problem. You must love Coca-Cola for this to happen.
But you can see my screen, yes, a picture.
Yeah, we can.
Yeah, okay. Yeah, so why would somebody do something like this? I can't imagine this. Coca-Cola is not paying for me for this. Yes. Is it good for my health? You know, if it's started time already. So I have been, actually they just threw me out from a PhD program. I was a PhD student for more than 15 years. And this is why I was a PhD student, is because I have a dream of lifelong learning, you see. So that, and to be a lifelong learner, there are two strategies. One strategy is to increase your learning time. The other strategy is to decrease your lifetime. And I am using, I am using the combined strategy. So together, this is why I'm using all this Coca-Cola and beer and cigarettes and stuff like this. Now, back to R and bad dates with R. What I want you to do now is load in this library lubridate. And to load it in, you would do library lubridate, conference. It again shows you some message in red. For me, it's blue, but for you, it's red. But don't worry about this. I will talk about this later. What does this all mean? And now let's read in one file. Let's read in one file, and the file is like this. That dates is read. Oh, Vitupalna, how does everybody? Okay, I see one person doesn't have it installed yet. Does everybody else have the lubridate and tidyverse installed? I should have.
Yes,
said,
reinstalled.
I should have told it before. Vitupalna, can you tell me when it's ready? I am going to show you something before, so let it install. I'm going to show you, just watch it, and you will be able to, when it's installing, then it will get ready soon. But depending on your computer resources and stuff like this, it can take some time installing, I know. Yes. Yeah, I know some of the countries you are from do not have the perfect internet connectivity. That this might be a problem. But I'm going to show you something, and don't worry about this right now if you cannot read it, because I'm going to talk about this first. So I'm going to read in dates file, and this is read CSV HTTP. I'm copying it to you in a second. I'm copying it into here, and I'm going to view this dates file now. It's copied into the chat, the address. So dates come in all the different formats, and some of the dates are really bad dates. For example, here is date one is, the first one is year, then the second one seems to be month, the third one is day. Date two, the first one seems to be day, the second one seems to be month, and the third one seems to be year. Date 3, it is day, month, year. Date 4, year, day, month. So it is amazing how many stupid dates you can find on in the wild. By the way, am I recording? Can somebody confirm?
Yes, it's recording.
Yes, yes, yes.
Good, good, because I cannot see it myself if I'm sharing the screen. Now, so it is amazing how many different dates formats are available. And in the wild, you see every kind of stupid dates formats, and it is something that you need, and every project you need somehow to convert the dates to normal formats. And for this, there is this package called Lubridate, which we installed and which we read in. Now, Lubridate is an amazing package. It makes everything with making dates and times. It makes everything very, very simple. And if you look at this dates dataset, first of all, again, if I do a summary of these dates, and then it shows that there are 4 variables, and all of them are character type. They are not date type, because R doesn't know what is the year, what is the month, what is the day. You have to explicitly say that this is a date variable. Now, Lubridate package provides you functions like day, month, year, or month, day, year. For example, day, month, year, if I put input to it that day is 01, month is 9, year is 1997, it says that this is 1997, 1st of September. This is how it integrates it automatically. For example, and let me show you another example. So let me say day, month, year, and now a string into it. So let's say day is, what is it today? 16th? 16, yes, 16.
Yeah, 16.
And month is 7, yes.
7.
So I write day and then I write absolute bullshit here. Now let's write 7 as a month, and now again some. And now let's write 2022 and console enter, and it is 16th of July 2022. It understands it. So you only have to tell it that the first number it sees is day, the second number it sees is month, and the third number it sees is year, and it automatically translates it. Now, if we look at these dates, how is it going? Charlie got it installed. Who else? Is there somebody who doesn't have it installed yet? Can't hear you. Well, I hope that you have it installed now all. So again, when you have it installed, then okay, Tupalna is still installing. Well, I'm sorry, but I'm going to continue now that you can when it's installed, then you can do it, because we have only 20 minutes left, and I want to get over this topic. So when you do library tidyverse, not tidyverse, but Lubridate, then it gives you all these functions, this DMI, MDY, YDM, all these functions. So let's look at the head of dates again. Head shows first 6 lines of dataset. If you don't want to see the whole dataset, you only want to see the first lines, you do a head or tail. Tail shows last 6 lines. If you want to show 5 lines, for example, then you can say n is equal to 5. Now it shows only 5 lines of the dataset. Then this date 1, as you see, the first number is clearly year. The second number is month, and the third number is day. So to tell R that so to tell R that you can to tell R that is the date, you need to do it like this. So I'm going to overwrite date 1, saying that it is year, month, day in this format, date 1, continental. And now if you look at this, if you do the summary again, summary of dates, then it shows that the first date 1, it shows you already that it has minimum, median, mean, maximum. It is a date, you know, if you do this class date 1, it shows that it is date type. It is not character type anymore. It is date type. Now R understands that it is a date. Let's do it with date 2 as well. So let's look at dates again. Head dates. Date 2, the first one is day, second one is month, and third one is year. So let's tell R that this is a date that's converted to date. Dates, date 2 is day, month, year, dates, date 2, continental. Summary of dates, and the second one is converted to date as well. Now R knows that this is a date. This Lubridate package, it actually is a very wonderful package. It helps you to do many things. For example, it helps you to find how many time intervals, how many seconds something is. For example, let me show you. Let's calculate how many months am I old. Or you can calculate it for your own age. Let's see. I was born in day, month, year 03/04/1978. And now I'm going to use a new operator that this Lubridate provides. Percent minus percent. This means that this is from one date to another date. It creates a time interval up until today. And now I'm dividing it by months, 1 month period. Control Enter, and I am 531.4 months old. Oh, let's see how many hours am I old? Not months, but hours. Oh, 388,200 hours. I will have a 400,000 hours birthday soon. Oh,
I'm not getting that. I'm getting something like this. UTC. What is this?
but did you do this divided by hours?
No, I did the first one, the months one, and I got this output.
Did you put percent minus percent in between?
Yeah, I did that.
And
This
then
this
divided
is what I did. Yeah, this is what I did.
months, not month, but months, but months.
Oh,
S.
okay, right. I'm sorry. Yeah.
So months, hours. You can also find it by weeks, for example. I am 2,310 weeks old. Excel, yes. Well, I am going to show you many things that Excel cannot do. But this is something that is very, very useful in practice. In practice, in many cases, you have dates or times, and you need to find the duration of some period, how long somebody was unemployed, or how long somebody spent on your website, or how long something took, and you can find it in months, hours, weeks, years, minutes, seconds, whatever. So for example, let's say minutes. Oh, what is it? This is 23 million minutes, 23,292 minutes exactly. So it's a birthday pretty much for me. I should celebrate. Now, there is now a small your turn in the file. It's on page. Oh, I missed one other your turn already. But let it be. So it's on page 4. Your turn on page 4 of the file Intro to R week 2. Now you will mess it up. Believe me, you will mess it up. If you mess it up, then there is nothing else to do than to load this dates file again. If you mess it up, then load dates file again, but start it like this. Dates, date 3 is. And now look at the dates, date 3. What is the first one? Is it year? Is it month? Is it day? What is the second one? Year, month, or day? What is the third one? Year, month, or day, and run it. I will be back in a second. I'll give you a couple of minutes for this. I am a bad boy. I did a cigarette. I actually quit.
Mr. Soko, sometimes we have one column of dates and rest of the columns are other data. So if you want to organize date based on days or years, first, what command we should use just for one column?
So, but here I'm doing it to one column at a time. So dates, date 3 is, if I look at it, This is one column. I'm doing it at a time. The other columns are left intact. So I say that dates, date 3. There can be other columns there. It doesn't matter. I hope my girlfriend never looks at the video, because otherwise she will find out that I did a cigarette. Charlie, you did something wrong. You have to load the dates again and then do it again. 9 failed to parse means that something is wrong, because everything has to be right. So dates, date 3, for example, is day, month, year, dates, date 3. And now don't run it again. If you run it again, then it messes everything up. But if you mess something up, load the dates again, then create it. So now it's date 4 is year, day, month, dates, date 4. Something like that. Oh shit, we are running out of time. I thought, for some reason, I thought that we will be quicker today, but I miscalculated time, so we will not reach to the ggplot yet today, but don't worry. Let's do this and then I think we will stop for today, and I'm going to, and then we will think when we will meet again, because there are some things I still need to show you. But okay, I'm going to do this. So the third one is the second your turn. This would be done like this. It's a little bit hard to do it, but maybe it's too hard for you now, but maybe not. So I'm going to create a new variable into dates dataset, which is called, let's say, difference. And I'm going to assign a value to it. And this value will be dates, date 3, up until dates, date 4, and divided by days 1. And now if you look at dates dataset, what did I do wrong now? It cannot be 0. Dates date 4. It has to be dates date 4 here, not dates date 3. And it now shows you the difference in days between these two dates. So this is something that very often comes up in practice. This kind of what that you need to convert dates to so that R will understand it. And now, by the way, it also understands months names.
Message, sometimes dates are mixed with the old and new days, like the previous days and the next days. If you want to sort the date by old and new, how we can sort the dates? Suppose there is 20 years in a lot of months, but some months are at the middle, like in 2000, 2010, 2011.
I am going to show it to you at one point how to sort datasets. For now, what you can do is you can look at view dates, and then you can sort it here. You can sort it here, but I'm going to show you how to arrange dataset by different variables, like by dates and everything else. Ovi, you have made some kind of mistake somewhere. You see, dates date 4 is not YMD like you write, but YDM. Ovi. So load the data again, load the dates data again, and do it again, dates date 3 and dates date 4. YDM it has to be. Okay, we have 5 more minutes to go, so I will not start a new topic, but I will actually I will actually stop the recording now, and we will discuss what will we do next.